Okay, yeah. Now this is a very interesting problem. Aram say contemplate and do it. So here the disk of radius r is rolling down the circular track of radius r. There is no slipping between the disk and the track. While the line OC makes an angle theta down the horizontal, center of the disk has velocity Vc. Center of the disk has velocity Vc. Direction they are not told. Assuming center O of the track as origin of the reference frame, find the angular velocity of translation of motion of the center of the disk and angular velocity of rotation of motion. Please take down this diagram and take 5 minutes, aram se resolve it, try to understand. See, first understand the mechanism. What is happening here? That means this disk is now rolling. This disk is rolling. Okay, so it is in contact with the surface. So at the contact there is going to be normal, and that normal is going to be the centripetal force vis-a-vis centripetal acceleration.
Yes.
All right, and there is a gravitational force vector which is gravitational weight vector acting tau. Okay, take those things into consideration and think. Okay, take 5-10 minutes and do it. No hurry. Whatever theory you have learned so far, you can make use of that and you can handle it. Okay? Now, first of all, how did you model this disk? For this case, how did you model disk? So, you see, you can use the concept of center of mass. So, center of mass of the disk will be at C. For the purpose of analysis, you can think that the disk is a point mass located at C, and then this C is moving in a arc. I think that will be the first model that you can do. Correct?
Yes.
So here you have this diagram and you have the disk here. Okay, and then you have a line drawn here, and this is O. Right? This is O, and now for the purpose of analysis, you can consider the mass of this disk to be concentrated at the center. So this will look like this. That is, there is a point mass here, but if you see the arrangement here, this point mass will move with omega.
Yes.
Okay, with respect to O, I will write it as omega naught.
Yes.
Okay, and this distance from here to here. So this total distance that given is capital R, and this the radius of this disk is small r. This is R and this is small r. Therefore, this distance will be R minus R.
Yes.
So
Yes,
omega naught will simply be equal to the velocity of this, translation velocity of this.
Yes, sir.
Okay. Translation velocity of this divided by R minus R.
Yes, sir. Yes.
Now what you have to understand is this point mass is going to translate along this path.
Yes, sir. Yes, sir.
This VC is going to translate along this. That means this path, if you draw like this VC bar will be tangential to this path.
Yes, sir.
Got it? So that means now you have found out the first part of the problem. What is the first part of the problem? To find the translation velocity of the disk. Now you should after having found out that, now you make the other diagram. So this, as you can see here, is a rolling with certain omega.
Yes.
So you have to find out omega from this data. Now that you have found out VC from this case, okay, omega naught you have found out, therefore VC will be equal to omega naught into R minus R.
Yes.
Now you should find out omega of the disk. So if you know VC and if you assume this is omega, if you know VC and if you assume this is omega, then and this radius is small r, you find
VC by R.
out that it is simply VC by r.
Yes.
So this is simply VC by, that is the problem.
Yes. Yes.
Not your math.
Yes.
No, from the diagram.
The way they mentioned.
They are not mentioned. They are not mentioned. Okay, sorry about that. No, they have said no. The disk of radius small r is rolling down a circular track of radius capital R. See, the thing is, I told you to take down the problem. So I gave you time for that. So what did you do during the time? So therefore, don't get start feeling something as soon as you see the problem. We as students of physics, we are interested in the physical variables. Given physical variables, that should be our focus. Okay, the problem is there is a narration. In the narration, they are saying this is this, this is this, this is this. We have to convert this data into information. What is the information? Radius of the disk is given, and radius of the arc in which it is traveling is also given. Small r, capital R is given. Okay, and they are given, that's the thing. And they have asked us to find out VC, and they have asked us to find out the omega of the disk.
Yes, yes.
So these are the only 4 variables. So this should not be difficult for us to keep it in our head and then handle it. Anyways, it's okay. It's a difficult situation, right? Fine. So shall we go on to the next one? Hello.
Yes, sir. Yes, sir.
See what we did here. See. Okay. This is the solution. All right.